Today we'll solve a challenging problem involving differentiation of an inverse trigonometric function. Let's start by looking at our question. Let's solve this step by step. First, we need to find y prime, which is the first derivative with respect to x. We'll use the chain rule here. The derivative of cosine is negative sine, and we need to multiply by the derivative of the inside function. Now, we know that the derivative of inverse sine is 1 over the square root of 1 minus x squared. Let's substitute that in. To make this easier to work with, let's multiply both sides by square root of 1 minus x squared. Now comes the tricky part. We need to find y double prime. When we differentiate y prime, we'll get several terms due to the product rule and chain rule. After differentiating and simplifying, we get this expression for y double prime. Then we multiply both sides by square root of 1 minus x squared. Finally, we can rearrange this to get our target equation. Moving all terms to the left side gives us 1 minus x squared times y double prime minus x times y prime plus m squared times y equals 0. And there we have it. We've shown that our original function y equals cosine of m times inverse sine of x satisfies this differential equation. This is a great example of how chain rule and product rule work together in complex differentiation problems.